Valentino. I work as an associate at Constructor Capital, which is a VC firm. But today I'm going to talk about, give you first some intro to Constructor Group and the Constructor Capital, which is a VC firm part of it, and how we do investing in quantum companies and what we have learned so far. Okay, so Constructor Group is a global institution founded in 2019 by Sir Bell. Basically, first he started by founding Schaffhausen Institute of Technology in Switzerland, and after that he also acquired the biggest private university in Bremen, Germany, previously called Jacobs University. After that he put this under one umbrella called Constructor Knowledge, and this is the entity which offers basically bachelor, master, PhD level education, as well as aiming towards leading research. So this is the first entity. In total we have 3 entities. The second entity is basically Constructor Technology. It's a tech firm offering products and research in space of educational technologies, AI, and this is something which Alexander will talk more about it later. The Constructor Capital is basically in the middle of this, trying to offer support to both of these entities. First, I'm going to start with our strategic advisory board. Here you can see that we have a majority of the people here are top leading scientists in the world, and 2 of them are also Nobel Prize winners, and among them we have 5 quantum physicists. This is to say that we're quite embedded in the scientific community, and we are trying to put great efforts in listening and of inputs we get from them, and trying to get closer and more aligned with the joint goals.
Was it many of the
These are
darker borders?
These are the quantum physicists.
Oh, okay.
Yeah. More about Constructor Capital, which is a VC firm. What is a VC firm? It's a venture capital. It's a type of investment fund which invests in startups. So we have 3 main investment areas. The first one is the software tech. We invest in mainly business-to-business software solutions. The second one is the deep tech. Here we focus on innovations coming from universities and research institutions, mainly in the space of physics, such as quantum, advanced materials, semiconducting, photonics, and so on. And the third one is educational technologies, where we look for software which improves the way we learn and the education space itself. Just to mention that in software tech and both in deep tech, we are also looking at AI stuff, which is very popular today. We have basically 5 main partners. I will start with Serge Bell. He's the mostly known. He's our co-founder and chairman. He's mostly known for starting Acronis, Parallels, Acumatica, and 2,000 other global IT companies across the world. Matthias Minter, he's ex-McKinsey, a senior partner there, spent 26 years, and he's our managing partner. It's interesting to say that among our partners we have 2 physicists by education, and in total among our team there is already 4 of us who are physicists. So we are early stage focused, meaning that we invest in pre-seed, seed, Series A, which means basically we go from the beginning towards, let's say, some later phases, let's say 5 years old startups, meaning our ticket sizes, when we invest, check sizes are from $100K to $5 million. I believe I mentioned everything I need to this on this slide. Yeah, maybe, yeah, it's a $150 million size fund. So this is the size of our fund, and how our ticket sizes, as I said, are going to up to 5 million. So we are completely geopolitical agnostic. We have partners ranging from different nationalities, from Singapore, Switzerland, India, and Cyprus, totally abiding the neutrality and inclusiveness of today's world. We have no geographical restrictions when it comes to investing, so we can invest all over the world. Usually it means that our 70% of our portfolio is under 8 hours flight from Zurich, our headquarters, purely from logistical reasons. That said, we are trying to leverage our non-restrictions of geography in our investments and trying to find the most attractive deals all over the world. As I said, our headquarters are in Zurich, but we have presence worldwide, and we have actually official opening in our Abu Dhabi office next week. So we are able to spread it. But it's also interesting to say that we are a completely remote working team with team members in Germany, Italy, Switzerland, Croatia, Cyprus, Abu Dhabi, Singapore, and India. In addition to just offering money to startups, which is their primary goal, obviously, to get money from us, we offer extensive access to our network of world-leading scientific institutions and also business networks of leading companies. And that's to say that for companies and startups, it's not sometimes it's as important to get money, but also to get access to network because it gives them higher leverage and higher probability of success. In the recent decades, we have seen quite big improvements in technological and changes on how we are doing business and how we are living, basically from internet era by today's giants of Google and Meta towards online space, guiding the customers towards offline brick-and-mortar stores to today's exponential rise of AI led by OpenAI. But we strongly believe that the next thing which is going to happen is quantum computing. We are not sure when it's going to happen because we're still in the phase of getting to the quantum advantage and practical usefulness, but we believe we are on the path towards it. That's why we are strongly focusing on it. Today, we are seeing already many quantum computing companies claiming that they have some kind of a product running quantum computing platform. Usually this means that they boast themselves with number of physical qubits. Unfortunately, the physical qubits are not offering us commercial or practical use which we are expecting from quantum computing systems. Recently, Quera, a neutral atom-based quantum computing platform, published an article where they showcased 48 logical qubits. But to get to any kind of usefulness or to start talking about quantum advantage, we really need to get above 100 plus logical qubits. Hopefully, this is something which we can see in the next 2 to 3 years. But here you can see how many logical qubits you need for certain different applications. It's very hard to get logical qubits, and there is, let's say, a ratio of 1 to 7, depending on the platform between physical and logical qubits. And regarding our investment criteria, so our team has invested in more than 20 companies, quantum companies, in the last 10 years. So here we set up some criteria which are not obviously the ultimate truth, but we hope that they can help in making decisions both for our investors and founders. First of all, what we look for is a solid research background. We want founders to have a clear, let's say, evidence of the research which is leading towards the product which they're marketing that they can build. Meaning that we want to see papers, citations, age indexes, embeddedness in the quantum communities, awards, presence on conferences, and so on. The second one is embedded leadership in chief scientific roles. Too often we see that the researcher, or PI or professor, develops something and then their postdocs or PhDs go and start a company, but the professor or PI stays on the sideline, not really being hands-on on this. He's his advisor 1 week, once or twice a week there. We don't want this. We want them to be fully present there, fully hands-on, because in the early stages of these kind of companies, we need technological and scientific advancements, which is needed. For this, we need all the possible effort from all the talent there is. And also it gives much more credibility towards this company from perspective of us investors, that we see that everybody's all in. And the second one is capability of securing non-dilutive grants. So this is the public grants, and this, as we can all know, that research is very expensive, equipment expensive. So we want to see basically one by one. So if you have a $1 million private investment, you want to have at least 1 million of non-dilutive public grants. This is making the business case more attractive also for founders, because they keep more of their company, and also for us investors. The fourth one is the setting of realistic product and financial targets. Unfortunately, too many companies go and say they're gonna change the world, and this is non-realistic, because it's not. They need to go and be realistic in towards how much money they will have and what they can achieve with this money. So this is in regards with what is available to them, but also in terms of what is the state of the art. They cannot claim that they're going to achieve something which is orders of magnitude better than what we have today. This is in terms of product targets, but also in financial targets. They claim that they can get to revenues of 100 millions in 2 to 3 years, but this is never going to happen. The fifth rule is basically leveraging university and laboratory networks. We want these startups to be embedded and physically close to universities and research labs. As I said before, it's very important that they have access to labs, then the costs get lower, and also they need to have access to top talent, and top talent is usually around universities and network hubs where there's PhDs, postdocs, and so on. And the last two are more general one, which we also apply to other kind of companies which we invest, is unique product value proposition. So basically we want the startups to have at least 10x improvements in the product, which at least in one area of the product which they develop. And the second one is we are not just a VC firm, we are bigger than, we are a group of things, and we want to leverage this and then obviously we need to be on the same side of as other startups are, and then that they want to have us being more on hands-on. I'm going to go towards a little bit explaining our current portfolio. So basically in our current portfolio we have more than 15 companies. Big part of them are deep tech, and 4 of them are quantum-focused companies, but not just. So there is also AI, computing, optical computing, and AI-based research materials. And here I'm going to finish with...
Acronis is not part of it?
No, Acronis is a much bigger company, like $4+ billion. So it's our team is embedded with them, but there's much more. Yeah. So Quera, this is one of the companies. Is like the biggest, let's say, our leading company in our portfolio. It's a neutral atom computing platform based out of Boston, and it's founded by top scientists from Harvard and MIT. Basically, they're already able to, and they already have a product online, which is a 256 quantum qubits quantum computer available on AWS cloud, basically. And they have, as I said before, they have showcased 48 logical qubits, and they have a clear roadmap, product roadmap in developing 100 qubits. Logical qubit system in the next 2 to 3 years. Another interesting thing for them is that they're most cost-efficient company. So they have the most results for the least amount of investment. It's also worth noting that we are the biggest investor in them. The second company is a quantum computing software company. So in quantum computing, we're not just seeing hardware companies, but also software companies. There is a clear need also for this, because as hardware is developing, we need software to control this hardware. It can be firmware, middleware, or direct application layer. Also, Kurus here is a German-based company which is developing software for accelerating research and lab experiments. Basically, we understand that operating quantum computers can be manpower intensive, and there is a need for software improvements and automation. The second 2 companies are in the field of quantum sensing. So Kunami is a Swiss-based company leveraging nitrogen vacancies in diamond atoms for use in magnetic sensing in materials. It's basically a research from University of Basel. These kind of companies are much closer to achieving commercial success, as the main efforts are among product development and technological improvements. And the last company is also nitrogen vacancy diamond atoms, but now focusing QDTI, focusing on biomarker detection with the goal of accelerating drug research and biological diagnostics. So basically they're able to go up beyond the current problems of background from in optical detection. And this is also founded by guys from Harvard, Chicago, and other universities in US. With that, I'm finished, and I'm thank you for your attention, and open for questions.
So I would ask who has some short question to ask now. Otherwise, we will have plenty of time during there will be a refreshment afterwards. Valentino will be here only tonight, so I ask whoever has interest in talking to him about what we just said to approach him during the drinks. There will be enough time. If there are now some clarification, short questions, we're taking them now. Otherwise, we move on. Okay, so I guess we can postpone to the discussion. There is a yeah. Anikin from Constructor technology.
Yes, exactly right.
Yeah. In our agenda, the last point is the demo Constructor. And the good news is that it's going to be only one demo. And I'm going to be as quick as possible because I understand that I'm the only guy who's standing between you and beautiful, relaxing dinner. And I hope that this product, which we built for researchers, is the most relevant for you for this specific audience. We started building it for researchers who are using computational methods in their research, like machine learning, artificial intelligence. And my question before I start, who of you guys are using machine learning or artificial intelligence methods in research? 3, good, perfect. 4. Yeah, not much, but I do hope that this short presentation will somehow attract your attention and you will think out about using this broader and more actively. So again, I will not be annoying you with some slides about Constructor technology and the product itself. I would rather show you how it works and on specific example. This example is taken from material science, and says that this research work was done by Konstantin Novoselov group, who is actually well-known, very well-known scientist, Nobel Prize winner, inventor of graphene. And what's the beauty of this article for us, for Constructor technology, is that all the computational analysis was done within this research using our platform. And if we scroll down to the very end of this article, we will find here references to GitHub, which is obvious. So any article should have this reference and keep the data in GitHub. But we also find here Research Constructor link. And if we follow this link, then we drop into the short description of the article, short description of the work which was done by a specific research group. You don't need any account, anything, just to have access to this information. All the data frames, data sets, publications available here. So it's just distributed by link. But the most important here is this button, duplicate. And if you press this button, for this you need account on research platform, Constructor research platform, and then systems start immediately recreating the absolute copy, clone of environment that was used by a research group of, in this case, Konstantin Novoselov, with all the artifacts, all the research content, everything, all the data sets, models, etc., etc. So it will take some time, but again, so of course it depends on the complexity of the model. I already have here the pre-installed and pre-deployed environments. And if we go to some environment, we'll find here this collaborative interface where you can check the publications that are related to this article. You can connect any computational resources for your compute. It might be Google, it might be Azure, it might be your university HPC or any other data center. You may create a group of researchers who are simultaneously working on the same project and have access to all the data, to everything, and some can bring data, some can build models, etc., etc. You can find here a beautiful data catalog that allows you to instantly review the results of research in 2D modes. In this case, it's 2D materials, crystal structures, but it can be proteins, it can be anything else, depending on the nature of the project. And then we can also create a link and share this link with anyone else, and then those guys will be able to also open the project and use it or reuse it or modify it depending on which whether you agree to share this content with them. Then if we go to the desk, what we'll find here the description of the project. We will find here all the data that was used. We can modify it. We can work with the workflows, just build new workflows or reuse existing workflows in environment using our data sets to either to reproduce the results of research work or get our own results. And of course, we can review the publications. We can work with the VS Code to do some new stuff and share it with the colleagues, and many other things. So you can use our own compute resources, or again, as I mentioned before, you can use your compute resources that are available to you anywhere. So this is quite powerful, interactive and collaborative environment that allows you to use, again, to summarize, different source of computation, computational resources, and work collaboratively on the same project with a group from one university or different universities, or it might be research project, it might be educational project. So you can teach students to deep learning, machine learning, and many other things. So this is very short. I promised you to be very short. Of course, you can try. I'm here till Friday, so you can ask any questions. And if you're interested to try this out, so I'll be here to provide you all necessary information. That's it.